Hello and welcome to Empowered Learning. This video is the third video in the video series that refers to finding probability of a data value chosen. Um, Part one showed us how we could find uh, the probability of choosing a data value that was, let's say, a data value 18 or less within a data set if we're given the population mean and population standard deviation. Video number two referred to the same sort of thing, but we did it by looking at z-distribution charts or tables, and we performed linear interpolation to be able to figure out what that particular probability would be. And so we saw that the probabilities were off some, but not by a whole lot. So this particular video, I'm actually using a binomial distribution type problem that we are able to approximate to normal distribution so that I can show you how do we handle situations where we have to find the probability of being able to choose a particular data value in between two data values, okay? So let's say if I wanted to know what's the probability of me choosing a data value in between 15 and 18, okay? Something like that. Again, the problem that I'm referring to here is a binomial distribution problem that can be approximated as a normal distribution problem. And I'm just using this to show how we actually do the probability calculations. So I'm not going to address the actual work that's in the problem per se. I'll go over it, but I'm not going to address all the little nuances of it. Okay. So this problem says that suppose for the same collection of data, which is in the other two videos where we had a population mean of 13.45 and standard deviation, and actually that value was a little different here. In our previous video, this particular value was 3.5177, but we're changing up stuff slightly here and making the standard deviation, population standard deviation, a little bit higher. So if you had watched those other two videos, we were using this number, but now we're going to use the one that we see. So with that being said, for binomial distribution, we test to see whether binomial distribution can be approximated as a normal distribution by doing these calculations here. And essentially what we're trying to figure out is n times p greater than or equal to 5, and is n times q greater than or equal to 5. Okay, and of course in this case we see that happens, so we can take this binomial distribution and try to approximate it as a normal distribution. Now the issue here is that binomial distributions are discrete distributions. They're not continuous. Okay, so because of that, we have to do some kind of what they call continuity correction to be able to basically stretch out what we know to be a continuous distribution and approximate it as a normal. Okay, and so the main thing that I want to focus here is that if we approximate this binomial distribution as a normal distribution according to the situation that I have here, because I want to figure out what is going to be the probability that I choose a data value that is exactly 18 from the given data set that I had in the previous two videos, then according to the continuity correction for this situation, we know that we have to figure out what's going to be the probability of having a data value in between 17.5 and 18.5. It basically just straddles 18, because we're doing that because for binomial distribution, you have these histograms or bar charts where this is 18 in the middle, and that's your 17.5, that's your 18.5. So you're trying to figure out, well, what's basically the area under the curve of this particular portion. Okay, so we start off by figuring out, of course, what is the corresponding z-score for 17.5 and for 18.5. And you see using the information, the mean, and this new standard deviation here, we see that we get our corresponding values. Okay, so roughly in terms of z-score, we're roughly dealing with something that is 1.1 standard deviations above the mean to 1.4 standard deviations above the mean. And so this is what this would look like on a normal distribution chart here. Well, actually wouldn't look exactly like that, but in general, it would look something like this. In reality, it would look something more like this. If this was the mean, then this would be the lower end here, and this would be the higher end there. Okay, so we were actually looking for the area under the curve between these two values here. Okay, I just wrote this here in general because if we had something that straddled the mean, this is how it would look. Okay, so moving forward here, so if we want to calculate what this is actually going to be, we want the data value in between here and here. Okay, and of course, in terms of z-score, we know that's going to be in between this 1.13 number and 1.41 number. Okay, now we know that that translates to, if we're looking at this in terms of cumulative distribution, we want to know what's the probability of having this data value here be less than 1.41 standard deviations above the mean. So here what this looks like is, if that's the mean and this is that 1.41 number, then that term is calculating the probability of all the data from z equals negative infinity all the way to 1.41. Here, what we're doing, same thing, but if this is 1.41 here, this will be 1.13. We're trying to find the area under the curve here. And of course, the difference in between this graph and this graph will actually be what we see here. That's the mean, 1.13, and this is 1.41. It will be this area here. So we take this area, subtract it from this area, and we get this area. And so that's what these calculations are all about. Now, how do we get these values here? This 0.92 number, this 0.87 number here. So here's where the calculator comes into play. So I'm going to erase this and then bring our calculator in and show you how we make these calculations. All right, so now that I have the calculator up, let's go ahead and do what we did in the very first video of this series to put in our values. Now, everything is, since we already have these z-scores, I'm going to go ahead and use the z-score to be able to calculate this, okay? So we'll go to second, vars, and then we'll choose option 2 again. And so part of the reason why I want to go ahead and just use a z-score is because, do you see I already have my population mean being 0 in terms of z-score and my standard deviation being 1. And so since we've already gone through the pain of calculating this, we're going to go ahead and use that number. So we come here, and that'll just be 1.132993901. And everything else pretty much stays the same. And we see we get this value here of 0.8739, so on and so forth. We'll do the same thing for this particular z-score, 1.4127. And of course, that goes along with the data value of 18.5. This first one here that we did, taking this z-score and getting this probability, is what the corresponding data value 17.5 is, okay? So right now, this data value 17.5, which has this z-score, translates to cumulative probability-wise that if we chose any data value that was 17.5 or less, there was about a 87.5% 0.14% chance that happens. So we're about to calculate the same thing for 18.5. So we'll go back in second vars, pick option 2, and then instead of having this 1.13 number, we'll just have 1.41274548.2, and then calculate the same thing, and we see that we get 0.92. So now all we have to do is take the difference in between the bigger number and the smaller number. So here I'll just come and copy this, minus, and then go up, hit the smaller number, and then take the difference, and we see that that would be the difference here, this 0.49743, so on and so forth. Okay. Now I'm going to go ahead and scroll down here so you can see that that's what we actually did. So we took this number minus that number, ended up getting this number, and this represents about 4.97%. So that means, what is the chance that I'm going to actually pick a data value that is exactly 18 from this data set? Well, it's about 4.97% chance that that'll happen based upon the data set, its population mean, and its population standard deviation. Okay, and so that's how we figure out how to find the probability of picking a particular data value within some range. Okay, and again, we used a binomial probability distribution problem that could be approximated as a normal one to be able to do this. But anytime, whether you're dealing with something that is just straight up Z distribution or not, even if you're talking about chi distribution, even though it's a different type of a distribution, the principles are the same as far as coming into your calculator and calculating probabilities. So of course, for Z distribution type stuff, you want to use what you see here. If we go back to here, of course, if you're doing any same kind of thing but T distribution, you want to use T-CDF. And if you're doing chi-squared distribution, then you want to use chi-squared. It looks like an X squared, but it's actually called chi-squared CDF here. Okay. So I hope this video helps and brings some clarity as to how we do this sort of thing. Let me know if you want me to do any more of these. It's been my pleasure. Take care.